see from the pictures, I'm Andy Hurley, Operations Director from Marine Zero.
And I'm Philip Twiddy. I work in clean energy investment in LCP Delta.
Right, welcome to our presentation, which is Putting Energy into Maritime Decarbonisation. And what we're going to be talking about primarily here is a project that we've been working on for the fair bit of this year called Electric Thames. And that's aimed at supporting the energy transition in the maritime sector, particularly on the central Thames area. And it's aimed at achieving the Port of London Authority's net zero target by 2040. So what we'll be doing today is to look at the energy supply challenges that we've got in that area and around the rest of the country, planning issues that affect how people can move forward with the decarbonisation, the costs, the impact of costs on it, both OPEX and CAPEX, and the options for vessel decarbonisation in that central area of the Thames. And that's mainly focused on battery electric and hydrogen use, and potentially the use of something like a green corridor to aid with charging. We'll be looking at what these solutions might look like. We anticipate taking about 30 minutes to talk through this, and then be available for about 10 minutes afterwards for questions. Right, over to you, Phil.
Thank you, Andy. So a little bit of background to the project and why did it come about. So the energy system knew that the maritime system needs to decarbonise, and they knew that there's an objective from the Port of London Authority to get to net zero by 2040, and there's wider objectives in the wider maritime sector, typically to 2050. But what the energy system didn't really know is, what does that mean? What will be the fuel? What will be the impact on the energy system? What would be the effect if that is uncoordinated? And what could it look like if it were coordinated? And so we started working with UKPN, the distribution business for the central London area, and with Marine Zero and ourselves, LCP Delta, to try to understand that. And so really what we're looking at is things like the effect of decarbonisation. What is the effect on the carbon emissions? What's the effect on the power system? What will be the solution? Where will the energy system impacts be? How big will they be? What will be the cost of that? And how could we turn some of these challenges into opportunities? And so what we did over the first part of this year was to look at things like the regulatory impacts. Andy's going to talk a little bit about that. We did a lot of stakeholder engagement, trying to, we spoke with lots of vessel operators, key operators, to understand what their thoughts were, what will be, understanding how they operate, etc. We turned that into what we call demand scenarios, so what will that mean to the energy system? And then we started looking at the cost benefit. And later on, we're going to talk a little bit about how we take that forward.
Yeah, so as Phil said, we looked at what the regulatory challenges and requirements were, really focusing primarily on this central Thames area, so primarily small and medium-sized commercial vessels. We all know that the state regulator for this is the Maritime and Coast Guard Agency, but on top of that we also needed to understand what the classification societies require and what their processes would look like. There is a defined process which the MCA have for clean fuels and clean propulsion systems. That system involves often the use of rules from the classification societies as well, and potentially where there are no regulations within the MCA through a risk-based certification approach. All of these require a significant amount of investment in time and need to be able to demonstrate a safe and effective method of operation. Part of that process is something called a hazard identification process or a hazard process, and that's a really long, lengthy, detailed examination of the operating characteristics and the safety elements associated with that. And that's an essential part of that risk-based certification process. So for the operators themselves, this is often seen as a barrier, or perceived as a barrier to adoption, because it's time-consuming, expensive due to the operator's own time, investment, and the costs from the classification society and from any external contractors, so naval architects or whoever else who might need to engage. The battery route is starting now to have a clearer direct route through, and the revised workboat code defines those requirements quite clearly now. So that's starting to diminish. With hydrogen, storage and propulsion, we're still using the risk-based certification process at the moment, and that's the one which is really challenging. Most of the solutions that we're looking to adopt will require electric power, and to achieve this, it will need the installation of new substations along the Thames to enable that power to be delivered in the right place. In the Thames, this creates quite significant challenges as well, away from the maritime sector wholly, because planning consent is required for installing these along the Thames. That's quite a challenging issue because there are 19, I think, separate boroughs who control the planning in the area that we're looking at, and each of them have their own planning policies. So as part of Electric Thames, what we're trying to do is to actually look at how we can coordinate that and find a way through the challenges that we get with the planning consents. And the other issue is around the residents' associations, where the residents who now live in lovely houses all along the edge of the Thames don't really want a big substation putting outside of their lovely houses or their flats or wherever they are. But somehow or other we have to find a way of enabling work to happen, or to facilitate the supply of power to the operators, the key operators and the vessel operators. So that's one of the challenges there. Thanks very much. So we now move on to the vessels themselves. As Phil said, we engage with the vessels, the vessel operators. We had fantastic engagement, it has to be said, throughout Electric Thames with them, and thank you to Julia and the PLA for supporting that, because that's made just a remarkable difference. So we saw pretty much all of the major vessel operators and a significant number of the smaller ones, mainly face-to-face, some on Teams and some through survey. What that enabled us to do is to gather information which represented over half of the vessels operating on the Thames, significantly more than half as it turns out. So really, really positive response from them, in that 100% of operators wanted to change to clean fuels. That's what they were saying very clearly. Mainly focused on battery electric and hydrogen, as I've mentioned earlier, with some combining other fuels such as methanol or ammonia. The main drivers were environmental benefits, followed by compliance and regulatory requirements. So it's interesting, I think, to see that the operators are really enthusiastic to do it, and their main driver in the response they've given us is environmental. It is followed up very quickly by regulatory, but I think there is a significant driver for them to be following the environmental arguments as well. A significant number of these were also interested in vessel to grid. And the advantages of doing this, we'll talk about it in a bit more detail later on, but what it can do is contribute to either CapEx or OpEx reduction in costs potentially. To enable us to understand how viable vessel to grid would be, we needed to understand what the operating hours of the vessels were and how it could fit into when the peak demand from the electricity suppliers would be. So we've done that, and about 50% of the vessels that we were looking at had a duty cycle that actually fitted in quite nicely with the peak energy demands from the suppliers. So actually there would appear to be a really significant opportunity there to maximise the benefits of vessel to grid. And as I say, we'll talk in a bit more detail about what that really means in a little while. What we also did was to look at the types of vessels that were operating and divide them roughly into 4 vessel archetypes, so we could start to analyse what other operators might need in different areas with the same sort of vessel types. So we divided them into workboats, or general workboats, the type of things you see in most harbours and ports around the country, tugs, passenger ferries and cruise vessels. And then using these, we got insights, as I say, into the working hours, the power demands, the type of use, what sort of fuels might be useful, and much more besides. So that's proved a really useful bit of research that we've done. And moving on to the key operators. Sorry, I have to use this because I can't actually read the screen over there. With the key, again, fantastic engagement. So we saw a significant number of the key operators who represented 23, I think, out of the 31 keys that are based in this central area. So it's really good representative sample, and as surveys go, I think it's really unusual for us to have had such a massively positive response. So a significant proportion again, really positive. Saw the advantage of vessel to grid as well, and keen to understand the opportunities that this might present. All of them stated that environmental drivers were important for them, and 75% of the key operators said also that regulatory drivers were things that were motivating them. All of the operators of the keys that we spoke to were interested in shore power, and about 80% of them were interested in vessel charging and vessel to grid operation as well. So very much the same as with the vessels, an overwhelming amount of enthusiasm and thought from the key operators in where they wanted to be seen as well. As I mentioned earlier on, the hours of operation for the keys and the vessel operators is not surprisingly reflected the earlier slide, with about half of the key operators stating that the period between 6 at night and 6 in the morning had potentially good access for vessel to grid. They're keen to explore that potential opportunity in most cases. The only limiting factor is really whether the key operator had space available on their keys. Some of them only own the keys themselves and have no land base whatsoever, which provides a little bit of a limiting factor for them. Hydrogen production storage, we've touched on just briefly, is seen as challenging in the Central Thames area. But through discussion, it's clear that with some of the operators, that there is potentially a good fit for them. So when we're looking at things like vessels with particularly lengthy operations, day operations, high power requirements, or speed and size of vessels, then hydrogen might be a better solution in those cases. So as part of what we do as we move forward, we'll be exploring that in much more detail. Okay,
So from the work that Andy led, or Marine Zero led, looking at particularly vessel archetypes and the operating patterns and the power demands, etc., we then took that through into some energy system modelling. And really we were looking at those things such as the vessel archetypes, the hours of operation, the power demands, and then looking at where that operation takes place, and then looking at two main things in the first stage of this project. One would be the impact on distribution business, and the second impact was looking at the impact on vessel operators and energy costs and fuel costs and energy costs and the savings that might be possible. It's worth mentioning that the project itself was funded by Ofgem as an innovation project, and part of that really means that we need to be looking at the impact on the energy system, looking at the benefits to the marine, but also looking at how that could be exploited and rolled out elsewhere. So when we looked at this cost-benefit analysis, we looked at various things that Andy has mentioned, but we're also then looking at what would it mean to the energy system, where would you need to site different power connections, what would be the extent of that power connection, how would those vessels be propelled, and we looked at the 4 different archetypes that Andy has talked about. So those different vessels, we simplified the world so that we could model it basically. It's a relatively short piece of work. And so that then allowed us to come up with the estimates for what would be the impact in cost terms on the energy system and what would be the impact or potential opportunity on the marine system. And we have a view as to how the vessels would be operated, but then you have options for how you might look to, if we're looking at a battery propelled vessel, how you might charge it. And we developed 3 different scenarios. The top scenario here is really looking at assuming that all of the charging is pressed into the cheapest part of the day, and that's the overnight peak. That's when there's least demand from the land-based system. There's plenty of available low carbon power. So that's when that's the time of day when energy is cheapest. So that's the first, but that has impact. So if you're going to try and do that, then clearly you need bigger grid connections, you need bigger vessel-to-grid chargers, etc. The second scenario, the middle scenario there, was just stretching out that overnight charging period, and that would allow you to have a slightly smaller grid connection, slightly lower powered vessel-to-grid chargers or vessel chargers. And the third scenario is flattening the peak a little bit further by assuming that there's going to be a point in time in the middle of the day when the vessels are moored and can be recharged and have a quick zap. And that allows you a third scenario. So we modelled those to see which of those might be the most favourable under various criteria. And that previous slide was just looking at the battery-propelled vessels. That in that section of the Thames that we were looking at, that's the majority of the vessels. And then we have a minority of the vessels which we would be looking to use hydrogen as the fuel source. So we then modelled the impact of that, and that's the green bit that's laid on top. And we just looked at 2 different scenarios here. One which is extending that peak in overnight peak and just trying to compress all the hydrogen production into that period, again because the economics might be that it's best to do that, best to run an electrolyser when power is cheapest. Or a second option, which is you're trying to absolutely minimise the impact on the electricity network, and you're flattening all of that hydrogen production into the whole day. Now, clearly these are just scenarios, and how the real world will actually work we'll find out in later stages. But that's really what we were looking at. So, and this is starting to tell us about what could be the impact on the electricity system. Yeah,
so moving on beyond the electric Thames to a degree is looking at what impact can what we've done here with the Thames have on the rest of the country and the maritime sector there. So calculating that impact for the whole of GB is obviously going to be challenging, given the much greater diversity of vessels that are operating, the operating behaviour, the greater distribution of that impact across many primary distribution areas as well. The vessel architects developed here will help without a doubt, but what they don't do is to cover the diversity of vessels across the whole of the UK. Further work will need to develop those archetypes, and we propose that data saved by ports using AIS could help us to achieve that. So as it's shown there, we can get a lot of data from that and help to develop what those future plans may look like. It's part of what we need to do from the Electric Thames project is not only support the PLA in achieving their objectives, but look at the whole of the UK market in terms of decarbonising maritime. I think one of the key things which we haven't actually stated outwardly is the link between the energy company, the DNO, in this case UKPN, in the centre of London, and the maritime sector. Quite often it's seen as almost an afterthought. We need energy, we've worked out what we need to do. Let's call the energy supplier and say, right, what we need is 10 megawatts of power here, please. And they say, yes, you can, but it's going to be 10 years or no. What this project is aiming to do is to give the energy companies a picture of what, in this case, the Thames power requirements are likely to be 5, 10, 15, 20 years away, so that actually they can do some proper planning around how their energy distribution is arranged, organised. And that same problem exists throughout the whole of the UK. So it's actually to put the maritime world into the minds of the DNOs to enable them to prepare properly and plan for what's likely to come in the future. So this is really important to enable the UK as a whole to shift across into that clean maritime sector. So be it for shore power, be it for propulsion systems, production of hydrogen or other clean fuels, all of those are going to require improved connections or increased connections to the DNO. I think that's probably it, yeah.
So back to the study on the central section of the Thames. So you'll recall the three graphs where I showed that maybe all of the charging happens in the peak or the trough of the night, or whether it's spread out over the night, or it's throughout the whole day. And so we then looked at the different costs, and that included the cost of the charging equipment, the cost of the electricity system upgrades, etc. And what we saw, based on those three different scenarios, that the difference between a coordinated rollout and an uncoordinated rollout could be at least £30 million on grid costs, and clearly that's going to need to be recouped either from the general population or from the customers who are requesting this. So there's significant potential to save it through a coordinated approach, and that's just on that central section of the Thames. If you're looking further east, then you look at bigger energy demands, and if you look across all of the harbours in Great Britain, you can multiply that out further and further. And then it comes to something that could potentially be really quite interesting, I think, for the maritime sector. So when we were talking about battery propulsion, then you can look at various ways of charging, and you can look at vessel to grid. So we looked at the potential for using vessel to grid. As Andy mentioned, there's operating patterns for the vessels. When we modelled the way that the vessels are operated, and the energy demand and the costs, and the way that the energy costs vary during the day, we identified that there's potential to save something like 50 or 60% of the fuel costs using vessel to grid. So what that means is timing the charging of the vessels so that it works alongside the way that the vessels need to be operated, but in coordination with the energy system, but also providing energy back to the energy system, so power back to the energy system. So there's a number of vessels that are not required or not operational during the evening peak when power is most expensive, and there's a seasonal effect as well, where fewer vessels are operating over winter. Again, the energy system is more expensive over winter, and that means that there's opportunities for making revenue. Now that then presents some quite interesting scenarios, that how could you perhaps use this to create an investment case that others can invest into the maritime sector.
Yeah, so key messages from Electric Thames so far. I think to start with, we were working very closely with Julia and the Port of London Authority to assist them in achieving their net zero objectives by 2040. That's still very much the aim of what we're doing. I think it was fantastic the positive attitudes and positive responses we had from both the vessel and key operators, with every single respondent recognising the need to decarbonise. And the level of response that meant that we achieved a response rate for the survey and interviews undertaken of well in excess of 50%, which, as I said earlier on, for surveys is just an amazingly high response level. The types of fuel solutions, as we've already mentioned, the Central Thames, electric, battery electric and hydrogen are clearly dominant, with some other fuels, but only in very small numbers. We haven't really given you any detail about it, but we're looking at the potential for a green corridor, a charging corridor, as opposed to the DFT definition of a green corridor. So having a charging corridor on the Thames, so the operators have charging infrastructure that they can use throughout the day, which they wouldn't necessarily own, because typically in the maritime sector at the moment, for commercial, the charging infrastructure is owned by the operator, or leased by the operator in some way. In this case, we'd have a different sort of model, but it would allow a lot of the vessels that currently may struggle to work as fully electric to be able to work as they could charge wherever they are on the river throughout their days of operation. Vessel to grid looks to be a really positive and potentially game-changing addition to the Maritime Thames and other locations. And that's particularly because of the potential impact of that on the OPEX and CAPEX costs. And what we've seen in Maritime generally, a little less I have to say in the Thames area than elsewhere, is that the CAPEX costs in particular are really prohibitive. Projects only go ahead when there's government funding to support them at the moment, because financially there hasn't been a model developed that works for them. What we think potentially with vessel to grid is there is an opportunity to develop a solution which could have a really widespread impact on how decarbonisation in these small and medium-sized vessels in the UK could happen. I think part of it also from the networks themselves, having whole system planning should reduce their costs as well, because if they plan ahead as to where all this additional power is required, then the development of their network can take into account maritime from the outset and not as an afterthought, and quite often a very expensive afterthought, with costs both for them and potentially for the operators as well. And I think working with the DNOs and Maritime together, and I think this is probably one of the first projects ever to have done it so closely, really moves us quite a long way forward in developing clean maritime solutions. And I think it's been a really positive project to be part of.
So we're now looking at the future, and as Andy mentioned, we're looking at this green corridor. So in the way that we define it, the type of chargers, where the chargers need to be sited, the power requirements, etc. So you can enable the Thames to be electrified. We're looking at the financing, so I mentioned some of the costs of that we've looked at already. We'll continue with that, and I think engineering design, so Andy and Marine Zero with partners will be looking at what are the solutions. So we've had engagement, there'll be further engagement with the operators to understand exactly how that could work and what would be the impacts on those vessels and the power demands. And then one of the things that is really quite exciting is understanding the business model, and that's really understanding the opportunity that to bring investment in and hopefully reduce the CAPEX impact, because that's going to be a significant barrier. So looking at the potential to overcome some of those challenges.
Yeah, so how does what we've done with Electric Thames impact on the wider maritime industry in the UK? So I think what's been really positive is just the amazing engagement we've had with the operators and how focused they are in trying to move into a clean maritime, a decarbonisation state. Well, another huge thing from this project has been working closely with the DNOs, in this case UKPN, but the other DNOs will also, I'm sure, engage in a similar way because it's beneficial to all. We've talked about the innovative solutions in terms of the cost models for trying to manage CAPEX and the impact of vessel to grid on that. And what we see really is that we'll continue to break new ground by bringing together the maritime sector and the energy sector to find real-world viable solutions to support the aims not only of the Port of London, but the wider UK market as well. It's a huge opportunity. Thank you very much.
Thank you.
Yeah, I think I can't give you a specific number, not surprisingly at this stage, because we've done early engagement really to understand the scale of the issue rather than resolving all of the challenges that are there at this stage. But I think it's likely to involve a mix, to be honest. With the Electric Thames, we've focused just on the Dartford crossing inland from there up to around Bridgman, where the commercial vessels more or less stop. So we've focused on that area, and that's why I've referred to them as sort of the medium and small size vessels rather than looking at the Panamax and all of the larger vessels that are further east. The targets that the PLA have relate to the whole of the river, and I think there is definitely work to be done looking at that area below the Dartford crossing to identify their requirements as well, but specifically within electric tenders, that middle section. So the next stage of what we're doing really is to work closely with quite a lot of the operators and actually build out or design what the solutions for them may look like, and we'll get an idea from that, and working with colleagues we'll understand what the power requirements are likely to be for specific operating parameters for a particular type of vessel. We can then use those using the vessel archetypes that we've got, which are broad archetypes, I understand that, and there's much more diversity there, but they cover a fair, reasonable representation of what is happening in that central area, because we've got the mix of the tugs and the other types of workboats, the cruise vessels who tend to just go in localised areas almost, and exactly as you said, the high-speed larger ferries like the clippers. So we're looking at all of those elements and trying to get a really good feel for exactly what sort of power is likely to be required and where it can be done. So part of the reason for raising that issue of the green corridor is that one of the barriers currently is that if the vessel operator only has the charging facility at their base station, their base port, quay, whatever, then they're probably never going to be able to achieve the sort of service that they need to do as a full electric solution. So they might look at hydrogen, but at the moment that's not very mature within the UK, so it's a really challenging one to invest heavily in a large vessel to do that until we get through this early adoption hurdle. So having a green corridor in place where multiple charging opportunities exist could actually have quite a significant impact on the availability of power for these vessel operators. So I can't answer your question directly at all, I've just waffled quite a bit there, but the intention is actually to try and get a better feel for some of those numbers, but proper real world numbers. So the intention is to design the vessels, design the type of vessel, the engineering side of it, the power requirements, cost all that out, because if we're looking at how we're going to build out cost models properly, we must know how much it costs to actually build all those things as well, and the operating costs associated with that, because we should know what how much energy they're going to use in a 24-hour period is going to be, and we can then build out that whole thing. So there's a lot more work to be done, so we're really looking forward to cracking on with that.
If I could also not answer your question, but give you some insight and hope. There's a couple more phases or stages to the project. So in the next stage, we're looking to identify a number of partners and really to understand what the decarbonisation plans are. So there's an end goal which might be able to give you the answer. We need however many. But as we get to 20, 30, 35, etc., there'll be more and more vessels that will be cleaner. And so we'll be looking to understand all of those plans in more detail, identifying a number of partners who might be ready, and then in 2025 we're then looking to take the project into the next stage where we're looking to actually deploy some of this. Some of the equipment, hopefully that will align with when the operators are ready with their vessels, and we can then prove that there is this investable model and prove that there is a solution that helps us to get there. So, too early to answer your question.
I mean, are you having good engagement with National Grid and the electricity stakeholders? Because obviously, again, knowing like the shore power unit down in Southampton, that took years to get into operation. If you're multiplying that across a densely populated area, it's going to put quite a challenge on the grid. The grid needs to be receptive.
Yeah.
Can I just jump in with my question, because that's related to exactly that point actually, and addressing the elephant as we've been using this morning. The biggest issue for anyone decarbonising and electrifying is getting access to that grid connection, and access within a reasonable amount of time, not 15, 20 years.
Yeah.
What is this project, what is Electric Thames doing? Does it solve that problem then? No.
It will certainly help us with that, yeah. So as I mentioned, it's a project that is primarily funded by Ofgem. It has a key distribution business, UKPN, because that's the distributor for that region. And one of the components of the next stage of the project is we will be identifying a long list of sites that we would like to put substations and vessel charging and anything else that's going to demand power. UKPN will be assessing those and helping us to turn that into a short list, but that's got to cover lots of other things as well. So whether that's about the planning arrangement, so you can't have a substation there for planning purposes, or it needs to align with the operators who are going to be ready to use it. So there's loads of factors, so we need to go through that. But to answer your question, yes, UKPN is looking to set up a dedicated team that will help to so when they get these things, I need a connection for a vessel, etc. They don't say, never heard of that before. And then that should then provide a template. So they'll help us to understand what information do we need to provide to them so that they can answer those quicker. And through this project, at least for the Thames, we then have this kind of timed plan for when we're going to need something. So I dare say it could be some delays at the start, but hopefully by the end it's just kind of happening because they know that there's a requirement at that in 2030 or whatever, etc.
Yeah.
So
I was just going to add a couple of things to that. So this is the first project I'm aware of where the DNO has actually been a really key partner within the project. That's critical because they're fully engaged in everything that we're doing. They understand the need to have whole system planning, which is what they're looking to try and achieve. And at the moment, as Phil said, when Marine Zero contact a DNO and say, oh, look, we've got a project here and we're looking for an increase in power, 10 times what we've got now or whatever, they either say no, or they put, because it's a really difficult question because you're talking to somebody who hasn't got any understanding of what is required within marine, or they give you a very long lead time of 10 years or something of that nature. And what we want to do is to allow them to, or enable them to develop a team who is specialist in, understands what the maritime sector is, who, as developers, we can go to them and say, actually, we've got this project happening in 5 years' time, this is what we're likely to be looking at. Can you, what support can you give to enable this to go ahead?
So just taking that, your answer there, what's the intention in the future then? Is it packaging up electric Thames and taking it to the Manchester Ship Canal or the Clyde or something like that? Is that the intention?
I think there are a number, I'll just first then I'll come back to you if that's all right. I think there's a couple of things which are going to come out of it. One is, I think the aims of the PLA to achieve net zero by 2040 are really key in what we're trying to support and help to achieve. So we've got to have sight on that because the area has been chosen with a focus on that. I think the other thing is, which is really critical, we've mentioned a few times, is the cost model, because currently projects only pretty much, there's a rule of thumb, only happen if there's funding from the government to support it or from some other agency of some sort. What we need to do to actually transition to full clean maritime operation where operators are doing it because it's a viable solution is to find a cost model that really does work. If we can't do that, then we're always going to be hanging on for some other external funding to support it, because if it doesn't make sense financially and operationally, it's going to be a real struggle to push it.
Phil, any quick remarks? We're running out.
Yes, absolutely. This is intended to create a template for how you could deploy across Great Britain and perhaps even wider. So understanding what do you need to address all of the societal problems, challenges, all of the planning problems.
And that leads me on to one final question, hopefully some quick responses. What suggestions do you have for solving those societal and sea-related challenges?
Yeah, I think some of the societal ones I've just mentioned briefly with regard to planning. So we find, particularly in the Thames area, Central Thames area, where there are very strong residents associations because they have these lovely houses and flats on the side of the river. They're making planning really difficult because trying to put a substation somewhere close to the river is being blocked at the moment, and we're finding that operators who are wanting to transition to clean fuel, even without funding actually on the Thames review, are really struggling with it because of that power supply issue. And I think society as a whole perhaps needs to look at, and there's a little bit of NIMBYism potentially with that, I think as we move down the Thames, it's probably less of a challenge, but certainly in that central Thames area, it's a real block, and I think that's a societal challenge for all of us, to be honest.
Okay, thank you. Thanks
Thank you very much.
Thanks, Andy.